There will be two videos this week. The first video will be on mean absolute deviation. I don't know that you have a lesson title actually on your lesson guided notes, but we're going to be talking a little bit about mean absolute deviation. The second will involve simplifying algebraic expressions. So, yeah, something that we've done in the past, but something that I want to review. I want to take some time over these last several weeks that we have of virtual learning to go through some of the topics that I know are going to be really important for you for next school year, including solving equations, which we've done, and now simplifying algebraic expressions. So mean absolute deviation will be the first topic of this week, and it's probably new for you. Oh, my son's making noise. Probably not something that you've seen in the past. It's not an extremely difficult thing to calculate, but it does definitely take some time to calculate. So you'll want to make sure that you take your time as you're working through the problems and watch this video, come back to it again, maybe take some notes also on this lesson as well, because it is something that you may not have seen before. So let's first begin by defining what mean absolute deviation is. Mean absolute deviation is the average distance between each data value and the mean. So we have the word mean involved with mean absolute deviation because we're looking at the average distance between each number in the set and the mean. So that's why we use the word mean. Absolute means we're going to be looking at essentially some absolute values. We're going to be looking at positive differences. And the word deviation, to deviate means to stray from the norm. So we're trying to figure out how far away each number is from your mean, how much it deviates from the mean. So the name itself makes a lot of sense. It sounds really complicated. I'll abbreviate it with MAD or MAD, but we will definitely be abbreviating this as we go to do some of our work. So there's three steps to finding the mean absolute deviation. So come back to these as you're doing your examples as needed. And assignment number one, by the way, is going to be on mean absolute deviation. It's going to be a pretty short assignment. It just has 2 questions, but I do ask that you show your work. So step one is to find the mean for your set. Find the average of the numbers in the set. The second step is to find the absolute or positive difference between each value in the set and the mean. So you're going to use this number from step one as many times as you have numbers in your set. So you're going to use this repeatedly. So you're going to find the difference between each number in your set and the mean. And then the last thing you're going to do is you're going to find the mean of the differences. You're going to find the mean again, but this time of the differences, how much each number deviates from your mean. So let's go ahead and take a look at 3 examples of working with mean absolute deviation. So number one, it says the following are scores on a math test: 80, 85, 81, 0, 85, 90, 87, and 92. And we can assume that 0 probably represents someone who maybe hasn't taken the test at this point, but we're going to include it when we go to find our mean absolute deviation. So part A, when we go to find the mean absolute deviation here, we're going to find the mean of the scores. Pause the video, take a moment, and find the mean of these scores. So hopefully the sum of your numbers is 600 when you add all those together. There are 8 scores, so take 600 and divide it by 8 to get a mean of 75. B, we're going to find the mean absolute deviation. So now we're going to find the difference between each number in the set and 75. So let me go ahead and show these. Notice how every time, and I'm going to highlight this, I'm going to use the number 75 every time. First number in our set was 80, so take 80 minus 75 to get a difference of 5. Second number is 85, so take 85 minus 75 to get a difference of 10. Our third number is 81, so do 81 minus 75 to get a difference of 6. Our next number is 0, so I'm going to switch the order around at this point, and I'm going to do 75 minus 0, because again, I want to get a positive difference. Our next number is 85, which I know we already saw before, so we take 85 minus 75 to get a difference of 10. Next number is 90, so we do 90 minus 75 to get a difference of 15. 87 minus 75 to get a difference of 12, and 92 minus 75 to get a difference of 17. And you notice for all of these except for this guy here, the 75 came second because all of the numbers in the set are bigger than the average. And the reason why that's the case is because our average is much lower. This is a good example of how much the mean or average can be decreased based on an outlying value like 0. So our mean in this case is going to be significantly lower than most of the numbers, again, because of that outlying value. Now, when I go to find the mean absolute deviation, so I did step 1 where I found the mean, I did step 2 where I find the difference between each number and the mean. Step 3, I need to do the mean absolute deviation. So I'm going to do the sum of all of the differences. I'm going to highlight those in green. So I'm going to add this guy, 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 and this guy together to get a total sum of 150. So when I add all these green dots together, I get 150. Divide by 8, since I still have 8 differences as I had 8 numbers, so you'll always be dividing by the same thing. And 150 divided by 8 gets me a mean absolute deviation of 18.75. Let's talk about what the mean absolute deviation tells us or what it means. This isn't something that a novice or someone who doesn't really work with statistics on a regular basis is going to use, but someone who does work with statistics and analyzing data will certainly use the mean absolute deviation. Because what this number tells us is that on average, each number in the set, each test score is 18.75 points or percent away from the mean. That's a pretty significant amount. I mean, a lot of times those numbers will be closer to the mean. And we'll talk a little bit about what causes that or what creates that in part D. So in part D, it says which score could be taken from the data set to make the mean absolute deviation smaller. Well, I mean, hopefully you realize you might be thinking, well, I'll take the highest value away. What we really want to do is we want to take that outlying value away so that our average is going to be closer to the numbers and therefore our differences are going to be smaller. We won't have that difference of 75 anymore. Now, I didn't calculate the actual change, but when you take that outlying value out, not only do these differences change, but your mean will also change as well. So your mean is going to become closer to these numbers, which is going to decrease these differences. And then when we go to find our average, it's definitely going to be, or our mean absolute deviation, it's definitely going to be much smaller because your numbers will be closer to what the mean actually is on average. So again, we could take the score of 0 out in that case. Let's try another example. Number 2, Emma and Sarah recorded their scores in the last 5 games of Number Crunchers. Their scores are listed in the table below. We've got Emma and we've got Sarah. Letter A is an analysis question before we go to do the mean absolute deviation for each person. Who would you expect to have the larger mean absolute deviation? Why? If you were thinking Sarah, you're correct. And the reason why her mean absolute deviation should be a little bit larger is because her data values or her scores are more spread out. So that means that whatever our mean is, each of her numbers are going to be slightly further away from that mean. Maybe not all of them, but several of them will be further away from the mean, which will increase our mean absolute deviation. So let's begin with Emma and let's find the mean absolute deviation for Emma's scores. So the first thing you need to do is find the mean of her scores. Pause the video and find the mean of Emma's scores. All right, so the sum of Emma's scores is 75. Divide by 5 since there are 5 scores. That's going to get us an average or mean of 15. So her mean score was 15. Now, the second step, which is a little tricky, is to find the difference between each number in the set and the mean. Again, the mean was 15, so I'm going to use it in each one of my differences. So I take 15 minus 15 to get a difference of 0. 18 minus 15 to get a difference of 3. It doesn't matter which one I highlight here, by the way. My next number is 13, so I'm going to take 15 minus 13 to get a difference of 2. The next number is 12, so 15 minus 12 to get a difference of 3. And my last number was 17, so take 17 minus 15 to get a difference of 2. So we can get a difference of 2 in two different ways, either 2 above 15, like 17, or 2 below 15, like the number 13. So these are my differences between the mean and each number in the set. Now I add those up. 0 plus 3 plus 2 plus 3 plus 2. That's going to get us a sum of 10 for our differences. Divide by 5 since we have 5 differences. And again, I was adding this number, this number, this number, this number, and this number to get 10. 10 divided by 5 data points is going to get us a mean absolute deviation of 2. So it means on average, Emma's scores are about 2 points away from the mean. Now, we assume that Sarah's would be a little bit larger, so let's calculate it. Pause the video and find the mean of Sarah's scores. All right, so the sum of Sarah's scores is pretty close. It's 71. Divide by 5, we're going to get a mean of 14.2 for her scores. Now we have to find the difference between each number in her set and 14.2. So take 19 minus 14.2 to get 4.8. 14.2 minus 8 to get 6.2. 14.2 minus 6 to get 8.2. 21 minus 14.2 to get 6.8, and 17 minus 14.2 to get 2.8. So the differences between our mean and each number in the set, I will highlight in green. We'll find the sum of those numbers, and feel free to pause the video at any time and do that on your own. So we'll go ahead and add those up to get a sum of 28.8. It doesn't always work out really nicely. Divide by 5, since we again have 5 green highlighted values, and we're going to divide by the same number we did for the mean. We're going to get a mean absolute deviation of 5.76. So on average, Sarah's scores differ by about 6 points from the mean. So that's a pretty significant difference between Emma's mean absolute deviation and Sarah's mean absolute deviation. Sarah's average is actually lower. Her mean is lower, but the difference between each score and the mean is a larger value. So maybe it means that Sarah's a less consistent player. So she, has scores that are pretty high, but then she has scores that are pretty low as well. So there's things that we can determine from this. Right now, our point is really just to calculate it, but statisticians and analysts will actually look at this to make assumptions and come to some conclusions about the data. All right, so last example. Number 3, the dot plots below show the top 10 test scores for each of Mrs. Winthrop's Period A and Period B science classes. So part A asks us to predict which data set has a smaller mean absolute deviation. What do you think? Remember, it says smaller mean absolute deviation. So if you said period B, that makes sense because the scores for period B are much less varied. They're all pretty close together. Whereas when you look at period A, they're a little bit more spread out. Yeah, I've got a 99 and a 100, but I also have them pretty spread out over all these values instead of clustered right in the center or towards the higher or lower end. So let's find the mean absolute deviation for both periods. So for period A, let's begin by finding the mean of those scores. Feel free to pause the video and do that on your own. So the sum of period A's scores will be 960. Make sure you're doing 92 plus 94 plus 95 times 3 plus 96 plus 97 times 2 plus 99 plus 100. Do not include 98 or 93 there because there are no dots. So the sum is 960. Divide by 10 since there are 10 scores to get an average or a mean of 96. So the average score, the mean score for period A is 96. Now let's find the difference between each score and the mean, which was 96. So you're going to notice I did some doubling here. So my first score I had was 92, so I took 96 minus 92, again, using that mean every single time to get a difference of 4. My next value is 94, so take 96 minus 94 to get a difference of 2. Then I had 395, so I did 96 minus 95 to get 1, and I put a times 3 here. Instead of writing it out 3 times, I'll just remember that I need to add 1 3 times. Then I had a score of 96. 96 minus 96 is 0. I still have to include it as one of my differences, but it's not going to contribute anything to the sum of my differences. I have 97 minus 96, but I have 2 of those. That difference is 1. Again, I'm going to need to add that twice. Next number is 99, so take 99 minus 96 to get a difference of 3. Then we have a score of 100, and 100 minus 96 gives me a difference of 4. So now I need to add up my differences. So I've got 4 plus 2 plus 1 times 3, so that's 3, plus 0 plus 1 times 2, so that's 2, plus 3 plus 4. Slide this up here in a moment. So the sum of all of my differences should be 18. Again, not forgetting that I have 3 ones here and 2 ones here. Get a sum of 18, divide by 10 since there are 10 differences, 10 scores, to get a mean absolute deviation of 1.8. And it's pretty clear here. I mean, the scores are all pretty close. You know, we're looking at a difference of about 2 percentage points from the mean. Let's do the same for period B. We did assume that this would actually be a smaller mean absolute deviation because the scores are less spread out. Let's see if that's true. Go ahead and find the mean for period B. So the sum of the scores for period B is really close. It's 961. Divide by 10, and you're going to get a mean of 96.1. So we need to find the difference between each number in the set and 96.1, the positive difference. I always do it so I get a positive value. So I've got a 94 in this set, so take 96.1 minus 94 to get a difference of 2.1. I've got 395, so take 96.1 minus 95, and again, I've got 3 of those, which is why I have this times 3 here. For 96, I'm going to do 96.1 minus 96 to get a difference of 0.1, only one of those. For 97, I'm going to do 97 minus 96.1, but I have 4 of those, so I put a times 4, so remember to add that 4 times. And then for 98, I do 98 minus 96.1 to get a difference of 1.9. So now we add those together. 2.1 plus 1.1 3 times, plus 0.1 plus 0.94 times, plus 1.9. You should get a sum of your differences to be 11. Whoops, don't want to move period B there. Sum of your differences is 11. Divide by 10 since we have 10 scores, and that will get us a mean absolute deviation of 1.1. It's not a significant difference because for both of them, your numbers are pretty concentrated there in the 90s, but it does have a smaller mean absolute deviation. So each score on average is a little closer to 1 point away from the mean instead of 2. So again, there's definitely some things we can determine here. Just a quick reminder before I give you an independent practice problem, I'll put it up on the screen here if you want to start it, is step 1, we're going to find the mean of your set of numbers. Step 2, find the difference between each number in your set and the mean. Add up the differences and find the mean of those differences. So divide by how many numbers you had in your set, and that will give you the mean absolute deviation. So pause the video and try the independent practice problem that's up here on the slide that you can see. It's our last question, but I think it's good to try one on your own before you do the 2 problems on assignment 1. All right, so hopefully you paused the video and you tried this question. Find the mean for this set of numbers, add them up, divide by 10 since there are 10 numbers. The sum of the numbers is 60, divided by 10 gets us a mean of 6. Now, for the next step, find the difference between each number and your mean, which was 6. So I had 2, so I have 6 minus 2, 6 minus 2, and 6 minus 2 for my 3 2's to get 3 4's. You could do it once and then just put times 3 next to it to remember that. I have 2 4's, so I do 6 minus 4 twice. I've got a 6. 6 minus 6, of course, gets a 0, but I still like to write it down so I don't forget that it's one of the numbers in my set. Now I have 7 minus 6. I have 8 minus 6, 10 minus 6, and 15 minus 6. Less repeated numbers up there. So my differences are, I'll highlight those in green, 4, 4, 4, 2, 2, 0, 1, 2, 0.49. So the next step I want to do is I want to add those together and divide by 10 again. So add them up. You should get a sum of 32 when you add all of these guys. Divide by 10, and we're going to get a mean absolute deviation of 3.2, meaning on average, each number is about 3.2 units away from your mean. Thanks for listening.